So good afternoon, everyone, to all TDS members and all other attendees. I'm Daniel Mroder. I'm today's host for this TDS webinar. This is the second webinar of our 2024 series, and we're looking forward to today's presentation, which is about engineered wood screws with the technical insights and design implications, especially for the New Zealand market. Before we go into the presentation, we have obviously more coming up. The next one is on the 18th of April. Still needs to be confirmed, but we're probably going to have a case study about a timber building in Tauranga. In the future, we have good and bad connection designs, manufacturing and quality assurance of CLT, and lessons learned on mass timber projects. So these are the potential speakers coming up. It has to be confirmed and will be sent through. If there's any topic of interest you would like to learn more, please get in touch. If you have a topic you would like to share as well, get in touch. We would be very happy to host you here on this monthly platform. These webinars are obviously facilitated by the TDS committee and by Engineer New Zealand, who are doing all the magic behind the scenes. So thanks to all of them. And also thanks to our sponsors being FutureBuilt, MyTech, Simpson Strong Tie, iBuild and Rothoblaas will be our speaker today. Now, before we go into the seminar itself, one last announcement you might have seen on social media and other platforms. New Zealand will be hosting the 5th International Conference on Timber Bridges on the 29th of June to the 2nd of July in 2025. So we're talking about next year's event, but being an international conference, all the organization is happening right now. And if you're interested, if you're working on timber bridges, an abstract, you can submit your abstract for potential presentation until the 10th of May 2024. More information will come through, obviously. And we as TDS are one of the co-hosts together with Waka Kotahi, New Zealand Transport Agency, for this prestigious event next year. Right, so the webinar today, again, engineered wood screws. Rothoblaas obviously is our world-leading supplier and also one of our sponsors. And we have Francisco, who will cover the webinar today. Now, Francisco sits in Italy, which has a 12-hour difference, and therefore the video is being recorded and played here today. And the other thing I need to mention is that the presentation is an hour long, so a bit longer than usual, but we will still do some Q&A later on. If you can't attend or if you can stay that long, please still pop in your Q&A in the link below. And one of us, or Francisco or Felix, who will facilitate, Felix Scheibmeier, who is the director of Rothoblaas New Zealand, will facilitate the answers and get back to you in writing later on. So quickly about Francisco himself. He's a wood enthusiast and holds a master in timber construction design from the University of the Basque Country in Spain. And he is now a technical consultant in Rothoblaas and is in charge of the Australian and the New Zealand market. It's great to have a dedicated person. And today he will talk about the technical implications of the connectors, mostly wood screws, based on the European Technical Approval, in short ETA, which you're hopefully all familiar with. And if not, today will be an introduction to that as well. And Rothoblaas' Smartbook for timber screws, which provides some information, practical information for design and construction as well. The presentation will show some details in terms of calculations, but also the implication of the capacities of those fasteners, especially in the New Zealand context, which should give you enough information for designing and specifying them for our timber buildings over here. And with that, I try to keep it a bit shorter, considering the long presentation coming up. I ask Caitlin to start a video, and please stay tuned and looking forward to the Q&A later on. Thank you very much.
Okay, hello everyone. Good morning over there. Good afternoon over here. It's a pleasure for me to talk to you this afternoon and this morning. My name is Francisco Rodríguez. I am the technical consultant from Rothoblaas here in Italy to the New Zealand and Australian market. And today, well, thanks for the invitation to this webinar. For us, it's a pleasure to talk to you about our products and our technical insights that we have developed for this construction system in wood that we work on. For us, it's really important that you guys in this market and other markets can understand really well our technical documentation and how have we developed this documentation so you have better tools to design the timber projects. By the way, excuse me a little bit, I'm a little bit sick, so I'm gonna be drinking a little bit of water. But yeah, hope you enjoyed this presentation. And at the end, we're going to have a space for questions to my colleagues over there in New Zealand. Okay, the presentation today is called Engineer Wood Screws, Technical Insights and Design Implications. Basically, the wood screws are the base of the design in timber structures. We sometimes think that the timber screws are just screws. They don't have too much technology behind, but as we are going to see afterwards in this presentation, actually the screws are a really important materials, really important connector materials that are developed with a lot of technology behind and that have a lot of varieties and a lot of aspects to consider. And we present these aspects, these technical aspects, and how do you calculate, for example, any screws, what the difference between one and the other. We have placed this information in two main documents, the ones that I'm going to present you in this presentation. The first one is the Smartbook for timber screws. Is basically a Smartbook that we developed to put all the technical insights related to the screws and other metal connectors for wood in just one document. And then we also have the ETA 110030 that is the main technical documentation for our screws. These are the main two documents, and I am going to show you a little bit quickly where you can find them. So afterwards this presentation, you go and you download them and you can study them. For example, for the European Technical Assessment, that is the ETA, this is basically a European documentation that the European Union asks for all the producers of technical products related to the construction and other aspects to develop. So we present clearly how our products are going to work, how are they calculated, what are they suitable for, etc. In this case, as you can see here, we are in the Rothoblaas website. In this website, you can find all our screws, and in each of the pages of the screws, you can go down where you are going to find the technical documentation. In this case, we have the technical data sheets, we have minimum distances guide, etc. And here you are going to find the ETA certificate. This is the document we are talking about, or we're going to talk about for the next few minutes, that presents basically all the technical insights of our screws. So this is our website. You can navigate there. It's really familiar and really a friendship website where you are going to be able to find basically all of our information. And about the Smartbook for timber screws, you can also find it on our website. Here I'm going to click and show you a little bit where you can find in this button that says catalogs. You can go down and you are going to find the Smartbook over here, right next to the plates catalog and next to the timber and screws catalog. Also, we have a minimum distances guide, and we have some other documentation that you can see and you can consult for free. There's no much trouble to download this documentation, because the idea is that you can have easily access to this information. So here is where you can find both documents. So hope you, after this presentation, you can go and download these documents so you can study them and make a deeper impact on your projects. Okay, so starting with the ETA, as I told you, the ETA is the European Technical Assessment, is basically the technical description of our screws. This document was developed to go further and to give a better understanding and description of our screws. because most of the screws in the market are developed with another documentation that is called the EN 14592. This is basically the most basic documentation for the timber screws. So we go further and we develop the ETA. In the ETA, basically, you can find all these parts that I show you here. We have a general part that is basically a description of the screws. And then we have the specific part where we talk about the specific issues of our screws. For example, we have a technical description of our product, of the products, like with geometry and materials. We have a specification of intended use. Of course, it's really important to say what these screws are for, what they should be used for. And also we have a description of the performance of the product. And with the performance, we mean about mechanical resistance, for example. We also talk about safety in case of fire, general aspects related to the performance of the product, and some more mechanical resistance and stability. Also, we have a lot of annex that we are going to see are really important. For example, this Annex A, what shows is basically the geometry of the screws. Here you are going to find in the document all the geometry aspects of the screws, the diameter of the head, the diameter of the body, the thread, etc. So for every screw, you're going to have one page with all the geometrical description, and there you can find this information. But also we are going to find, for example, the minimum distances, the compression reinforcement, and other important aspects for our screws. It's important that in this presentation, I'm going to show you like parts of the ETA. We are not going to read them all because, of course, it will be really tiring. The idea is that you have fun today and you understand better the document, and later you can go and read the document by yourself. The first part of the documentation basically is a description of the product. So basically, it describes the geometry and material of the products. Here, it's important to explain to you that, as I said before, the screws, wood screws are not just screws. They are different kind of screws for different uses. And for example, here in the description, we mentioned basically the 5 basic families that we have for our screws. We have the screws that I put in yellow that are basically the HBS, the TVS, are the screws with partial thread. These are screws more used for carpentry connections. They have partial thread, so they can put together the components. Then we also have the green, in this case, green screws. These are structural, well, more suitable for structural connection screws. They are more rigid because they have a full thread. Also, they have different kinds of head. And then we are going to have the DG set, that is basically this purple screw. This screw is used to attach the insulation of the facades in a structure. Then we are going to have the blue screws, these ones that are more used to connect steel or metal plates to the wood. And finally, we have the orange screws that are more suitable for exteriors, for decks and for pergolas and other kind of structures. In this case, as you can see here, we have all these screws described here with the codes that we have, that you can also find in our catalogs and in our website. Also, this part talks about the diameter that these screws should have, that it should not be less than 3 millimeters and not greater than 20 millimeters, the diameter. And also it talks about the overall length, that it shouldn't be less than 20 millimeters and more than 1,200 millimeters. In this side that I put here in the top right corner, in the bottom right corner, sorry, I highlight the main materials these screws are designed for. we are talking about solid timber, glue laminated timber, cross laminated timber, LVL, and similar glue members. I mean, these screws are suitable for timber-based components or timber-based materials. This is, as you can see, a first description of the product, what is it suitable for, and what we are talking about in this document. Afterwards, we now start to talk about more specific issues of the screws that are really important to take into consideration for the design or also for the use of this kind of products. In this case, for example, we talk about the insertion moment. You already know probably that if you are going to put a screw inside the wood and you use a really strong tool to install it, maybe the screw can break. And this always can happen because the metal, it's inside its properties, it's something that can happen because it has a range where it can work. Well, basically, in this ETA document, we mention this range where our screws, the metal our screws are made of, can work. So we talk about the insertion moment, that is basically the moment you apply into the screw, and the torsional strength. The torsional strength depends on the material and the diameter. So you can see over here, we have a column with the diameters and a column with the torsional strength. If you put this number inside this formula, you are going to find the insertion moment, that the top insertion moment that you should use, or well, you should use less than that, so you are not going to break the screw. That's how you find it. And in the right of the screen, you can see something that I took from the Smartbook for timber screws, because these two documents interrelated one to the other, because of course we mentioned some issues from the ETA in the Smartbook and from the Smartbook in the ETA. In this case, for example, in the Smartbook, we talk about the insertion moment, that is basically this force that we apply to the screw. This force is going to depend also in the pre-drill that we do. For example, if we don't do pre-drill, if we do a pre-drill just the half of the screw, or if we do a pre-drill for the total length of the screw. In this case, you can see that, for example, when you have a pre-drill, the insertion moment is always lower than the extreme insertion moment that you should not achieve. But when you don't have, this is for softwood, but when you have hardwood, and depending on the different conditions of the pre-drilling, you are going to have different situations of the torque applied to the screw. And therefore, for example, in the case A, that you don't have any pre-drill, the screw is going to break. So this is really important to take into consideration more as a practical advice that we give you, that you should not apply more than this torque in a screw so you don't break it. Then we also talk a little bit more about this pre-drill. This is also from the Smartbook in the right. We talk about the necessity of pre-drill when the density of the wood is higher than 550 kilograms per cubic meter. And here you can see a table where it says what's the hole diameter that you should use, depending on the outer thread diameter of the screw. This is really important. Our screws also mostly of the time work with the outside thread diameter. This is a big difference from other screws that are in the market. Here from the Smartbook, you can see in this image the difference it can make in terms of damaging the wood, the difference it can make the pre-drill. For example, here we don't have any pre-drill, so you can see how the fibers of the wood open. So in this case, the red sting can go in. And in this side, you can see when we make the pre-drill, there is no much damage inside the wood, and therefore the screw is more suitable and more attached. Well, the touch is the same, but the damage in the wood is better. And we also talk about the pre-drill hole diameter in the Smartbook, but well, this is something that you can take a look on. But this is a really, really important issue, especially with hardwoods, that I understand that you in New Zealand and Australia work a lot with hardwoods. Well, mostly of the times it's recommended to have the pre-drill in the hardwoods, even though we have some screws that are designed special for hardwoods. It's better to always test and to always make the calculations to define if it's necessary or not the pre-drill. Okay, after these issues of use, installation, and so on, we started to talk about the mechanical resistance of the screws. Okay, how do we calculate how much load, for example, shear load can take a screw, or actual load can take the screw? Well, in the ETA document, we define the procedure to calculate these capacities. As I show you here, in the ETA it says that the calculation should be done based on the Eurocode 5. The Eurocode 5 is the code for designing timber structures in the European Union, and I show you here in the green box in the right the formulas that are included in the Eurocode. These formulas have been developed from the Johansen theory. Basically, Johansen developed these formulas for a shear failure of a connector, depending on if the failure is going to happen for the compression of the wood, for the plasticity of the connector, or for both in this case, for example. So you see here all these formulas that at the beginning it can seem really complicated, but actually they are not that complicated. And why? Because I am going to show you where can you find all of the variability or variables of these formulas. To start with, in the ETA document, we talk about the characteristic yield moment. The characteristic yield moment is basically the moment where the material of the screw change from the elastic side to the plastic side. It's the moment when you apply this to the screw, it is going to pass to the plastic side. So in the ETA, we mention all of the characteristic yield moments for every diameter of our screws. So as I show you here in a blue box, you can take this number from our ETA and include it here in the blue marks in the formulas. To include the other aspects, we are going to have the embedding strength. That the embedding strength is basically the capacity of the wood to be compressed. Of course, it is going to depend on the capacity on the density or the wood that you are using. So as you can see here, we are going to have in our ETA the formula or the formulas to calculate the embedding strength. It is going to be based on the density, characteristic density of the wood that you are using, the diameter of the connector, and the angle that is placed the connector to the fibers of the wood. We have different formulas because you can read in the paragraph before that it depends on, for example, in this case, the angle that you have to the grain. And for example, if you have or not pre-drill holes. In this other side, we have the formula for LBL that I understand that you use a lot in your country, in non-pre-drill holes in LBL and in pre-drill holes in LBL. Over here, we have, for example, the formula for the embedding strength in beach LBL. That is a really, really hard material. So based on these formulas and on these variables, you can find your embedding strength, the FHK, and put it in the formulas of Johansen that are taken from the Eurocode. Johansen developed different formulas depending on if there is just one plane of shear or if there are two planes of shear. And also depending on if all the components are wood or if you have one component of wood and one component of steel, for example. In this case, well, before I presented to you the one plane shear here, and here you can, oh, sorry, there you go. And here you can see the images, the graphic explanation of two plane shear for pieces, just wood to wood connections. The other aspect that we have in the Johansen formulas is the axial withdrawal capacity. This is also a really important aspect to define the capacity of the screw to tensional loads, right? When you try to when you have the screw and you try to take it out, this is the axial withdrawal capacity. The axial withdrawal capacity, it says in our ETA how it should be calculated. It is based on the actual characteristic capacity of the material that the screw is made, the number, efficacious number of the screws, and it means effective number, how many screws do you have in that connection, and some other variables that you can find over here, including the effective length, that is basically how much of the screw is inserted inside of the wood component. For the characteristic withdrawal parameter of the material, here I put an example, but in the ETA you are going to find there is a lot of characteristic withdrawal parameters depending on the material, depending on the screw you are using. For example, here we have LBL with 410 kilograms per square meter, or other characteristic densities. You are going to find different parameters that you have to include in this formula, so you obtain the actual withdrawal capacity, and with that you come and include it here. This is really important because this part of the formula that says Fx divided in 4 is talking about the rope effect. Basically, the rope effect is the implication or the let's say the way the actual capacity of the connector is going to help with the shear capacity, because when the connector starts to bend this way, the actual capacity starts to play a role. So this is important to include. It is also important that the aero code establish a limit where the actual capacity should be taken into account depending on the kind of connector that you have. If it's a nail, if it's a screw, if it's a bolt, or anything. But yeah, it's important that you take this into account. And here in the bottom, you can see the graphic for these formulas, that these formulas are for the connection between a wood element and a steel plate element that varies its thickness. Depending on the thickness of the connector, you are going to have to use different formulas. All of this, you can find it in the aero code, and the information that is placed over here, you can find it on our ETA document. Other important aspects that are present in the European Technical Assessment that we have for our screws is the mechanical resistance and stability related to the head pull-through capacity. Basically, this talks about what's the capacity when you take the screw from the head. I mean, when you, for example, have a piece of wood, you have the screw inserted, and you have another piece of wood in the top of the screw, and you are taking from that other piece of wood, not from the screw properly, but when you let's say the capacity depends on the head of the screw. This is really important because if you need a really high axial resistance, probably you will need to use a screw with a really thick head to have a better resistance. In this case, we say that the actual head pull-through capacity can be calculated with this formula. That is basically depends on the F head, that is basically the characteristic head pull-through parameter that we establish, and that you can see, you can find in the ETA document, depending on the material, depending on the particular screw that you are using, and you can find the number here, and then you take also the characteristic density and the based density for the calculation to apply the formula. Okay. In this case, it is really important that when you do this calculation, you also take into account that the diameter of the screw is really, really important, same as the other formulas. And to finish with the mechanical resistance and stability, it's really important to make the calculation for the combined loads. This means when you have a screw loaded in both shear and axial, you should make the verification that this formula that it talks about basically the capacity of the screw divided into the demanding load plus this in axial plus the same but in shear is going to be less than 1. So you are sure that if at some point the screw is submitted to both loads at the same time, it can take it. I mean, it can take it because it can happen that the screw is good enough for axial, is good enough for shear, but when you combine them, the screw may fail. So that's what we are avoiding with this calculation. All of this, as I said, is described in the ETA document, and it is important that you consider all of this. Talking about minimum distances. The ETA also talks about minimum distances. It is important that you understand this concept. We talk also in the aero code, we talk about minimum distances because if you put a screw really close to the border, really close to the side, the wood may fail. Therefore, if the wood fail, there is not going to be capacity. Even though the screw is really, really strong, but there is no wood, so the connection will fail. So we have to use the minimum distances to be sure that we have enough wood, enough material in all the sides of the screw to take the loads. Okay. So in the Eurocode you can find some minimum distances, but in the ETA we include them too, because the minimum distances from the ETA much of the time are lower than the ones established in the Eurocode. So we are improving the capacity and we are improving the details, technical details for our screws. Here you can see when you place screws in 45 degrees, you have the A1, that is basically the distance between them. We also have the A2 CG, that is the distance to the border, to the side border. And we also are going to have the distance between them and the distance when you have cross screws. I put this here just to show you an example of what's the minimum distances we are talking about. In the document you can find all the details, but it's really important that the minimum distances are always described in terms of the diameter. That means that depending on the diameter of your screw, that's the distance that you should have. Why? Because of course it's not the same having a screw of 5 millimeters with X distance to the border that having a screw with 12 millimeters, for example, with the same distance to the border. The screw with 12 millimeters is going to press more the wood, is going to affect more the wood, and therefore the wood is more suitable for break or for fail. And therefore we need more wood, so the minimum distance is increased. Something really, really important about this issue too is that when you make the pre-drill, the minimum distances decreases. Why? Because as I showed you before, when you make the pre-drill, the break of the wood and the damage of the wood is less, and you're going to have a better result of the connection. I include here also the specification for the LVL that I understand that you use a lot in your market. We have specify clearly what's the procedure to calculate the minimum distances for the LVL. We have the spacing parallel to the grain, perpendicular to the grain, unloaded grain, loaded grain, and unloaded edge and loaded edge. The loaded and unloaded depends on where the load is coming from, and if the edge or the end grain is or is not loaded. If you need more to get deeper into this, we are here to help, and you can contact our team in New Zealand so you have a better explanation. But it's really clear in our ETA and also in our technical data sheets that you can find online. About, well, the same about minimum distances. This is to show you that we also include the minimum distances for CLT. This really new and great technology we have, that we have developed a lot of products for this kind of technology. They are also specified for the CLT in the ETA. This was what I was talking about the minimum distances, the importance of leaving enough distance between the screws. For example, in this case, we have the screws really close to each other, so basically the wood can open and is not going to work in the middle of the screws, and also to the border. This kind of failure is really, really common in wood construction because mostly of the people or the people that doesn't know about this put the nails or the screw really in the border of the piece, and if it doesn't break at the moment, it probably is going to break afterwards when the load is applied. So we have to be really careful with this. And as I told you, I'm not going screw by screw or product by product because it would take forever, but these are numbers that are really clearly specified in our technical documentation. Another important issues included in the ETA to close about this document is important that you know that we specify the procedure to calculate the compression reinforcement. This is basically a reinforcement we do to the wood to improve their capacities of compression perpendicular to the grain. You know that depending on the species and the type of wood, it has a limited capacity compression perpendicular to the grain. So for example, in this case, if you apply this compression here and the beam is by himself, probably is going to fail sooner or later. So we put these screws, full thread screws, perpendicular to the grain to help taking this compression and avoiding the failure. So this procedure is clearly specified in our ETA in the Annex C. So you can take a look on it and in case you need it. But it's really important that as our screws, we design them for this kind of use, we also specify in the technical documentation. Same for the tensile reinforcement perpendicular to the grain. You probably know that, or when you have this kind of cut in the beam, or for example, when you have a connection that is not going to include the whole height of the beam in the connection, there is the chance that when you apply the load in the top of the beam, there can be a failure parallel to the grain. You know that the wood is like little straws, one in the top of each other, and when you apply a load, this can happen, and this kind of failure can happen. And that's why we have specified our full thread screws to make a reinforcement perpendicular to the grain that cross from one side to the other of the beam and attach all of these layers so they are not going to open after they are loaded. Okay, so this is also clearly specified in the ETA, the formulas and everything to calculate this kind of use. Okay, so that's all for the ETA. As I told you, I don't want to go really deep into the numbers and product by product because it would take forever, but it was basically a description And the document is really clear. You can download it, you can take a look on it, study, and in case you need some more information, you can write to me or write to my colleagues over there, and we will be happy to answer your questions. Okay, about the Smartbook, this is a document that we developed some years ago, like trying to explain several issues that are related to our connectors. Not just about the connector by itself, but mostly because of what is outside the connector that affects the connector, right? Because we are aware that even though our products are really good, they can be installed in a infinitive variety of environments, of issues, or wood species, and a lot of variety. So it was really important for us that everyone in the market can understand these aspects that are related to the behavior of the connector, but are not part of the connector. So this Smartbook is really a nice job from our colleagues here that we've developed with a lot of research, with a lot of tests, also with a link with some universities. And what is included here? Well, we have first a part of theory that talks about, for example, corrosion of the screw. Corrosion, yeah, is the screw, but is related to the environment, to the wood species, to a lot of issues we're going to see afterwards. We also have a part that talks about shrinkage, sorry, I don't know how to pronounce this word, and swelling. We also have the fire, we have the applications and connectors, and we have the materials. This is like the theory behind our screws and behind its behavior. And also we have some practical inputs, some practical insights mostly for the people that is over there in the side building with wood, but also is really important for the professionals that design these projects, because it should be taken into account so the project has a better it gets to a good port, let's say it that way. Here in the practical area, we talk about minimum distances per drill. I already talked about it with the ETA. We have the insertion moment, we have the timber to timber, metal to timber, and the screwdrivers. Some important details about the installation of our screws. Okay, so talking about corrosion, basically corrosion depends a lot on where is the project located, where is the screw going to be placed. The first issue about the emplacement of the screw is the service class. The European normative Eurocode 5 established 4 service class. The first one is when you have, let's say, inside environment, the internal environment. You have a really controlled humidity. You have your wood that is around 10% humidity. You have, like, everything is controlled, everything is good, no problems with moisture, no problems with water. The service class 2, now you are getting a little bit closer to the water, a little bit closer to the humidity. You are external but covered, which means that you have a roof that can cover your structure, but you can get in touch with humidity in one way or the other, you know, with raining and then coming the rain, or I don't know, you make a deck for parties and you know that people is going to throw the liquids, or I don't know. So you are more a little bit aware of the appearance of water. Then you have the service class 3. The service class 3 is exposed to water. It is completely external, as you can see here. There we have different kinds of service class 3, but the main thing is that the humidity of the atmosphere is going to be higher than 85%. The humidity of the wood can be 18%, and so on. So you have a really external conditions for the connector. Therefore, you should install or you should design with a connector suitable for this condition. And the service class 4 that is included in the new Eurocode, the past version doesn't have it, is basically the external, but also in contact with water. It's basically saturated. We talk about ports, we talk about structures that are inside of the water. Basically, it's structures that are completely saturated. It's really important to understand where is my project located so we can choose the right connector. Other important, really important issue about the corrosivity is the atmospheric corrosivity class. It basically depends also in the placement of the structure, not related to the rain or to the sun, but more related to the air. How much corrosivity chemicals do we have in the air? For example, are we in the beach? Are we close to the factory that is producing salt or something like that? So here you can see the 5 different corrosivity classes established by the Euro code, by the EN 14592. That is the code we based for the primary design of our screws, and then we make the ETA. This norm talks about 5 corrosivity classes in the environment, and as you can see here, it depends on the moisture of the environment, the exposure to chlorides, and the exposure to pollutants. You can see here the description. It basically depends, as I told you, if you are close to a place that has a lot of corrosivity. For example, the farms for cows or industrial production, mostly of the time they, let's say, pollute a little bit with some high corrosivity chemicals that can affect our connectors. This is something also really important to take into consideration. For example, I'm not sure if you have snow over there, but when you have snow, you also probably going to have the salt that they throw to take away the snow in the streets. So this salt is going to be a really high corrosive material for our connectors. Another really important issue, we already have the service class, we have the atmospheric corrosivity class, and now we have the wood corrosivity class. Depending on the wood, the species of wood that you are using, you can have a really corrosivity wood, because the wood have something that is called the pH. That is basically the acetic acid ester that acts through inside the wood that may corrode the connector. We have different, well, we have also 5 wood corrosivity classes over here that you can see. But it just not just depends on the pH of the wood, but it also depends on the wood treatment. For example, back in my country, I'm from Costa Rica, and in Costa Rica we use a lot the pine treated to build in the outside. But this treatment of the wood could have a really high impact on the corrosion of the connector, depending on the material, right? Depending on what are they using to make this treatment. But it's really important that you talk to your I don't know, the company that you are buying the wood from, to see if the wood by itself is corrosive or the treatment that it has. Also, it's really important the moisture content, because you know that depending on the content of the wood, that can be more or less corroded for the connector, and the service class that is also related to the wood species. So taking into account these three variables. Oh, sorry. Before that, we also include in the Smartbook this little, let's say, graphic that shows the pH of some mostly used species, wood species. We can see, for example, the teak over here with a pH of 5.1. We can see the ulmus with this pH. These are the less corrosive wood species, the T3. But in this side, we have the T4 that are more corrosiveness, with more corrosive for the connectors. We have the beech, We have some African wood, so it is important that you, when you are going to build with local woods, you try to find the pH of this wood, so you are going to choose rightly the connector starting from there. How? For example, with this graphic we have over here. In this graphic, we include the atmospheric corrosivity class, the C that I told you before, the T, the wood corrosivity class, timber corrosivity class in gray color. We have the atmospheric corrosivity class in purple. And we also have over here in the outside of the circle, you can see the different materials we have for our screws. This is something really important. We have some different materials to build our screws. We have the steel, the carbon steel, zinc treated. That's like the most basic one, like that you can see over here, that it says zinc, is zinc coated. Is suitable, for example, for atmospheric corrosivities 1 and 2 and timber corrosivities 1 and 2. But we also, starting from there, we are going to have the EVO. The EVO is over here, you can see it. We have also the C4 and the C5 EVO. That's basically a skin we put in our screws that has aluminum and particles of some resin that we develop to protect the screws in front of the corrosivity environments. This is important because the screw is not stainless steel, therefore is not so expensive, but it's really good to take the corrosion. So this is a really good product, for example, for the beach or for other environment that is really corrosive for the screws. Also, we have the organic coating that is an important coating for some conditions. You can see here that the C4 and the C5 are, let's say, established for a atmospheric corrosivity class until 5. That means they are really good. Also about the wood corrosivity, we mark here the ones that are certified, but we put in light gray, in this color, we mark the ones that we think from our experience that are suitable, and is not certified, but we can say that they are suitable. And then in the other side, we have the stainless steel. We also have some screws in stainless steel. It's important that you understand that stainless steel is a really good material for corrosiveness, but it's not a really good material mechanically speaking. If you need a really high shear resistance or high mechanical resistance, probably the EVO is a good option, because the EVO is made out of a material that is really mechanically capable, but with a good corrosive capacity. On the other side, we have the stainless steel that is also really good for corrosion environments. But yeah, the mechanical resistance is not that high. And here we have another page of the Smartbook that talks about, that Rothoblaas has, we have a lot of screws, but we also work a lot with plates. We combine our screws with some plates, especially designed for timber, and we make the connection from let's say, from a timber structure with the plates. Also, of course, these plates are made out of metal, and they can be really affected by the corrosivity. So we put here in this graphic, we put the environmental service class that I told you, the atmospheric corrosivity class, and the wood corrosivity class, and we mark here if any of these connectors, depending on the metal they are made of, are suitable for this condition. So if you have your project, you know the service class, you know the atmospheric corrosivity class, and you know the wood corrosivity class, you can come here and find your screw and your plate, at least the material. Of course, the size and all of these details depend on the connection and the loads and everything, but at least you will know the material. For example, here we have this kind of T-shaped plates that are made out of aluminum, and of course the aluminum has no problems with the corrosivity. This is something This is also something that has to be taken careful. In the Smartbook, we talk about a little bit about the let's say affection it has, how does the material from a connector affects the other metals. This is something really important, a chemical process that you should take into account. It's not just that I put aluminum, that I put stainless steel, and that's it, because when they interact, they are going to, maybe they can provoke some problems depending on the environment and the timber you're using. So this is something important to take into consideration. Another important issue we have about the timber, of course, is the fire. You know, the timber is a material that reacts to fire really in a really interesting way. The timber burns from outside to the inside with a ratio of, depending on the wood species, it can go between 0.5 or 0.7, 0.8 millimeters per second or per minute, depending on the rate you are using. So that means that if the fire comes to a timber structure, to a timber shape, to a timber material, it is going to start burning from the outside, but the inside is going to be stable. This means that placing the connectors inside of the timber makes that the timber protects the connector. Why? Because the connectors are made out of metal. And what happened to the metal materials when they are exposed to high temperatures and fire? Well, they melt. They pass really easily to the plastic range, and they fail really easily. So in this case, we have, in the Smartbook, we have these graphics that show you, for example, the graphic on the right, they show you how the capacity, the structural capacity of the metal decreases really fast with the fire. But in the other side, we have the wood, which structural capacity remains, or well, yeah, decreases, but decreases really slowly with the time, making suitable that the firefighters can come in, can take out the people can escape, etc. I mean, the structure is not going to easily fail. And that's why we say that the timber it's a good material for the fire. Of course, it should be designed to take the fire. So we design, for example, a beam with a section, a base section to take the loads, and then we put an extra layer of wood, so this extra layer can take the fire and can, let's say, burn without compromising the structural capacity of the structure. How does this affect the connectors? Well, the connectors, if they are inside of the fire, inside of the wood element, they are going to be protected, but at some point they can be affected. How the connectors affect the timber, or how much heat can they transfer from outside to the timber, depends on a variety of issues. The length, how long they are. For example, well, in this chart you can see the worst behavior are the little screws, because they get really warm, and because and also the long screws, they get really warm on the head, but on the front they are not going to be that warm, and they are not going to affect the wood. Also, the diameter is really important. Here you can see how the bigger diameter makes a bigger damage in the wood compared to the little diameter screw. And also we have a different behavior on the material, because the thermal conductivity of the materials vary. For example, the stainless steel screws has less thermal conductivity than the zinc electroplated screws. So all of this has to be taken into consideration when you choose a screw, especially if you are designing, taking into account the fire. To finish this part of the Smartbook and the screws, it's really important to talk about the difference between the full thread and the partial thread screws. As you can see here, the partial thread screws give less stiffness to the connection. Why? Because as shown here, in this connection between two pieces, you apply a shear load here, and in the wood element that is on the top, there is basically no link between the screw and the wood element. It is just acting by compressing the wood. It doesn't have a thread that connect to the wood. That's why when you apply the load, it is going to easily fail because it doesn't have anything to link the two elements. On the other side, the full thread screws that we see over here, that are screws that we always recommend to place 45 degrees, they have the thread linking the screw to the wood element, and therefore when you apply the load, they make a really good they have a really good behavior, and the stiffness is really high. One of the connections that we really like, that we really promote is this connection. When you have a main beam or a column and you have another beam, you put two screws 45 degrees from each side, taking the shear load, but these screws have to be full thread. Why? Because one screw, as it can be seen here, one screw is working in compression and the other screw is working in tension. But if you have one screw that is not full thread, of course the compression here is not going to be able to be taken, because as I said, there is no thread that link the screw with the wood. So there is like a freedom of movement over there, and therefore there is no capacity to take the loads. This is something is really important. You can take a look on the Smartbook to understand a little bit better. We have a lot of detail about this issue in the documents, and well, you can take a look over there. About the materials, we also talk about different kinds of materials and where they should be, how can we place them. For example, here we have structural softwood and structural hardwood, and the necessity of doing pre-drills depending on the wood that you are using. Also, we have the drills and everything to make the work more complete. And another really important issue that we have we have done a lot of research recently about this issue is the one of the questions that we get the most: can I use impact drill machine or no, or should I or no? This is a really important issue because when you apply impact in the screws, it make a degradation. It can provoke a degradation on the material of the screws that later on with the time is going to make that the capacity of the screws is going to decrease. Also, it is really important, if it's possible, to measure the insertion moment, so we are going to be sure which are the moment we are applying to the screw. We also have some tools that work for this in our tools catalog. So yeah, it's really important that you are aware of this, which tool is your company or your builder using to install the screws, because it can really affect the behavior of the screws in the long term. So this is something really important. And also, it's really important to be aware of the conditions in the work site. That, for example, you sometimes can design a project with a defined humidity content, but you don't know if when they build the project it's going to rain, it's going to snow. You are going to have different humidity conditions, and therefore the humidity of the wood can change, and it can provoke some corrosion or some other problems with the behavior of the connectors. So yeah, this is something also really important that you should take into consideration. this final part, I did it a little bit faster because I was running out of time, but I really invite you to go to the website, download the Smartbook, download the ETA, read it, study it. It's a really, really good tool that we are giving to you. It has a lot of important information. If you read it and something there's no clear, that is not clear, or you have another question or another input or anything you want to talk about, here is my mail. You can write to me. I am the technical consultant for New Zealand, and I will be happy to talk to you, to know about your projects. We also have a really good commercial team over there, that they are also really technical, so they are aware of mostly of these issues. And yeah, thank you very much for listening. It wasn't that boring, and we are happy to help. We are here to build more with wood, to make the wood industry bigger and bigger every year, because we believe that building more in wood, we are helping our planet, and we are growing as human beings. So thank you very much, and I stay here waiting for your mails.
Well, obviously, big thank you to Francisco. He's not online, but we'll pass on the thanks later on. But I do have Felix Scheibmeier, who is the director of Rothoblaas New Zealand, here with me now. And although we are already a little bit over time, perhaps we can do a few short, simple questions. And if you have more questions, please pop them in right now or contact Francisco or Felix directly. Perhaps we can add Felix's email to the chat so that everyone has access to that as well. So welcome, Felix. There's a few questions coming in, and although Francisco has explained it in long and short about pre-drilling, there's a question about should all screw pre-drilled, and I think it's worthwhile to reiterate this aspect quickly if you could. Yeah, thank you, Daniel. Look, I think it's not an easy question to answer, right? It depends on a lot of different factors. So the screw type, the timber that you're working in, a lot of what Francisco already covered, the edge distances that you have available. So obviously the changing of edge distances with pre-drilled versus not pre-drilled. So from my side, I would say the simple answer is, should all screws be pre-drilled? No, a lot of screws will have a self pre-drilling tip, right? Especially with the constant improvements there. But you should be cautious, especially when you're working in the higher density timbers, for factors like your torsional limits on your screws. So there it becomes more important to consider the issue for sure. Thank you, Felix. Another question, which is more like product related, question is how many of your brackets are readily available in New Zealand? And perhaps if you also want to mention screws. I mean, also it's a difficult question, but for someone who is new to the engineered wood products, engineered fasteners, Rothoblaas SRL, maybe you can provide a quick overview. Yeah, so I think to simply answer that question, there's a good stock in New Zealand of the main products, so things like your WHT brackets, your Titan brackets that are more common in the CLT space, or let's say the prefabricated stick frame space. Screws is the same, so things that we're using in a CLT lap joint, for example, we tend to always have off the shelf in New Zealand. What I would caution against is if you're working on a larger project, please don't expect then if your builder gets in touch with us the week before and wants 50,000 of the same screw type, that will be in stock. It's very unlikely to be. It could be, but it's unlikely. And I think that doesn't just go for us. It's any kind of engineered fixing that you're dealing with. Once you get into those larger projects, it's worthwhile getting in touch early, or noting in that design phase that whoever is picking up the project from a construction point of view should get in touch with us. So simple answer, yes, there is stock. But obviously the bigger the quantities get, the more chance there is that it's not completely fulfillable from New Zealand. Especially, given I think our project line now with 3,000 or so different products in the line, it's simply not possible to hold everything in stock here in New Zealand. Thank you. Last two questions. One is Someone is asking, Würth has screws or screws with special tips where you can use distances for pre-drilled holes. Does Rothoblaas have something like that too? I think it might be worth talking about the new screw range or screw tip coming through, Felix.
Yeah, so we are in the process at the moment of changing over to what we're calling a 3 thorns tip. It's a newly designed self-drilling tip that's a bit smarter, let's say, than the old Type 17 or closer to a Type 17 tip that we had on a lot of the screws. The best way to look at that from a design point of view is to have a look on our website. If you click on, say, a normal countersunk screw on the right-hand side, it will prompt you with a minimum distances guide or minimum distances guide comparing tips. If you click on that, that will give you all the information on the different edge distances that you're then dealing with. So the new screws have significantly better edge distance requirements, let's say. And from that point of view, you can take a look there just to understand. 2 comments with that. Some of the screws will only swap over in 2025. I say some because we're also adding new screws to the range, so very long and very large diameter screws, for example, which are new to production, so they will swap over later than the ones that are currently part of the product mix. But by mid-2024, most of the screws will actually have switched over. The one thing that will happen, though, is that we'll roll those out as we obviously run out of current stock, right? We're not going to throw away any of the current stock that we have. So if you've got a project where you're relying on this minimum edge distance or the new minimum edge distances, then it's worthwhile just getting in touch with the team and explaining that, and we can look at how we can best deal with that.
Perfect. Thanks for that. Last question. There's a few more, but perhaps Francisco can answer them in writing then. There's 2 questions related to compliance, essentially. One is specific to Australia, but I want to extend it more to New Zealand as well. Obviously, Eurocode isn't as acceptable solution or verification method to the New Zealand or Australian building code. What's the take in terms of designing some of those products in the New Zealand, at least in New Zealand context? Not sure if you want to extend it to the Australian context as well.
Yeah, look, we can probably very quickly look at both. I mean, from a New Zealand context, you're often in the alternative solution pathway, right? So from this point of view, I don't really see an issue with working within the Eurocode. Obviously, we have the new timber standard out now, and that's a lot closer to the Eurocode. So I think from that point of view, for larger projects, it's fairly straightforward, to be honest. Or there's not much, well, I don't see any downside, actually. From a smaller project point of view, we're looking there a little bit at how we best tackle that problem. So we have done some testing, for example, for truss to top plate screws or stick framing type screws, where there's specific testing data then available to support that. The Australian side of things is a little bit more difficult. So there, it's more or less the same approach, right? So the National Construction Code over there, you do have the chance as well to work in a similar space. That alternative solution, it's called something different. I can't remember what the term is over there, but it's the same or similar system. I guess the issue that we have is that the new standard is not yet accepted over there, so we're not quite sure which way that will go. And until we know that, we're probably reluctant to completely go through redesigning for a standard that we don't know if it will be accepted or not. So it's a little bit of an on the fence situation. I realise it's not ideal, but that's probably where we sit at the moment.
Thank you, Felix. I think that sums it up. If I can just add, even for a small project, if a screw is designed to alternative solution, councils are aware of those products. And alternative solutions not always trigger a peer review or any other mechanism straight away. Just consider that LVL, as it stands, isn't in the design standard, and as such would be an alternative solution, but no council asks a question because it has been accepted. So most councils, I would think, accept engineered wood screws as such. So I wouldn't be too scared of using either Eurocode or the new standard for the specific design of a single screw. That is my take. But obviously things are changing. new standard is out there. It's not cited yet, but again, people will get used to it, council will get used to it, and it should make specification of screws, engineered wood screws, a bit easier moving forward. I leave it at this. So thanks everyone for attending today. Obviously, big thank to Francesco, and obviously also to you, Felix, for the answers you have provided. And yeah, both Francesco and Felix are available for any of your queries moving forward. With this, thanks everyone, and I'm looking forward to the next webinar on the 18th of April. Thank you very much and goodbye.